Welcome back friends. Today we are going to study a little bit of chemistry, biomolecules. Let us start with the basic definition of biomolecules. But before that, if you see the word biomolecules, you can see we can divide it into two, bio and molecules. Bio means life, and what does it suggest? It says that there are certain molecules which support our life, whereas they constitute the living system. Now, the definition says biomolecules may be defined as complex lifeless organic substances which forms the basis of life and are responsible for the growth and maintenance of the living system. This means that there are certain complex lifeless organic substances which form the base of our life, the very basis of our life, and are responsible for the growth and maintenance of the particular living system. Now, they are lifeless, but still they constitute and help in the growth and maintenance of the living system. Under biomolecules, we have carbohydrates, proteins, vitamins, and nucleic acid. Today, we are going to cover a little bit of carbohydrates. So, let's move on to carbohydrates. Now, starting with carbohydrates. There is a common general formula for carbohydrates. That is CxH2O whole power Y. Now here the value of X and Y is not always same. Like if we see the case of glucose, it is C6H2O whole power 6. Here the value of X and Y is same. But if we go for deoxyribose, it is C5H10O4. Here the value of X and Y is not the same. So we can see that there is a common general formula for carbohydrates, that is CxH2O whole power Y, and here the value of X and Y is variable. Like in case of glucose, it's same, but in deoxyribose, it is different. Now let's move on to the definition of carbohydrates. The definition of carbohydrates says that carbohydrates are constituents of polyhydroxyaldehydes and polyhydroxyketonic compounds, but on undergoing hydrolysis, they give polyhydroxyaldehydes and polyhydroxyketones. Let's write it down. Carbohydrates are optically active compounds of polyhydroxyaldehydes and polyhydroxyketones. Which on hydrolysis give polyhydroxyaldehyde or polyhydroxyketone. Now, let me tell you something about the definition. The definition says that carbohydrates are optical active compounds which are formed of polyhydroxyaldehydes as well as polyhydroxyketone. And when they undergo hydrolysis, they either give polyhydroxyaldehyde or polyhydroxyketone. Like if I give an example, taking the example of sucrose, C12H22O11. It is formed of glucose as well as fructose. Now when it undergoes hydrolysis, it gives C6H12O6 glucose plus C6H12O6 fructose. Now, even though we know that the formula of glucose and fructose is same, but glucose contains an aldehyde group, whereas fructose contains a ketone group. And the sucrose is formed of glucose and fructose. That means it has both aldehyde and ketones. So, as per the definition, the aldehyde and ketone, when they undergo hydrolysis, they give either aldehyde or either ketone. I hope this is very clear to you. Now, let's move on to the classification of carbohydrates. Carbohydrates are classified based on 5 bases. And I will explain you them one by one. Starting with the first one. The first one is hydrolysis. Based on hydrolysis, we have divided our carbohydrates into 3 categories. Into 3 categories. That is monosaccharides, oligosaccharides and polysaccharides. So, based on hydrolysis, we have 3. Monosaccharide, oligosaccharide and polysaccharide. So this is it. Hydrolysis, monosaccharide, oligosaccharide and polysaccharide. We will see one by one. So first moving on to monosaccharides. Monosaccharides are those which do not undergo hydrolysis. Now, examples of monosaccharides are glucose, fructose and galactose. And the formula of this is C6H12O6. So, glucose, fructose and galactose, 3 of them have the same formula. Moving on to oligosaccharides. Oligosaccharides are those which are undergoing hydrolysis give 2 to 10 units of monosaccharides. Now, examples of oligosaccharides are sucrose, lactose and maltose. They all have the same formula. C12H22O11. Now, I am telling you, when sucrose undergo hydrolysis, it gives glucose and fructose. That we have already seen. Moving on to our polysaccharides. They are the one which on hydrolysis give more than 2 to 10 units of monosaccharides. So, polysaccharides are those which are undergoing hydrolysis give more than 2 to 10 units of monosaccharides. Polysaccharides, we have a equation like C6H10O5N. When it undergoes hydrolysis, it gives 10 molecules of glucose. Now, polysaccharides are of 3 types: cellulose, starch and glycogen. So, this is the thing. Based on hydrolysis, we have three: monosaccharides, oligosaccharides, polysaccharides. Monosaccharides are one who do not undergo hydrolysis: glucose, fructose, and galactose. C6H12O6. Three of them have same formula. Oligosaccharides are those which are undergoing hydrolysis, yield 2 to 10 units of monosaccharides. Examples are sucrose, lactose, and maltose. They have also same formula: C12H22O11. Sucrose on undergoing hydrolysis gives glucose and fructose. Polysaccharides are one which are undergoing hydrolysis, yield more than 2 to 10 units of monosaccharides, and the formula that when undergoing hydrolysis, polysaccharides give N molecules of glucose. And there are three types: starch, cellulose, and glycogen. Let's move on to the second one. That is our reducing power. Hope you have written this. The second basis of classification is reducing power. Based on reducing power, we have again divided carbohydrates into two. That is reducing sugar and non-reducing sugars. So this reducing sugar and non-reducing sugar. Reducing sugars are all monosaccharides except sucrose. All monosaccharides except sucrose. Now, what is reducing power? Reducing power is the one that is the sugars which can reduce tolerance reagent, Fehling solution, and Benedict solution. But non-reducing sugars are those which cannot reduce tolerance reagent, Fehling solution, and Benedict solution. So here all the monosaccharides except sucrose. That means non-reducing sugar is only one: sucrose. So this is on the basis of reducing power. Monosaccharides except sucrose are reducing. Non-reducing is our sucrose. Now, I want to tell you that reducing power is what? That is the one which can reduce tolerance reagent, Fehling solution, as well as Benedict solution. Now, let's move on to the third one. That is our functional group. On the basis of functional group also we have divided into two categories: aldoses and ketoses. Now on the name, by the name only we can understand that one contains aldehyde and another contains ketone. Based on functional group, we are again divided into two. Aldoses, ketoses. So aldoses contains aldehyde group. Ketosis contains ketone group. So this is on the basis of carbohydrates classified on the basis of what? Functional group. Functional group: aldoses, acids, ketoses containing aldehyde group containing ketone group. Like for example, for aldoses we can have our glucose, and for ketoses we have fructose, because fructose contains ketone group and our aldoses glucose contains an aldehyde group. Now based on the fourth category, we have number of carbon atom. Based on number of carbon atom, we say them as: for 3 carbon atom we have triose, for 4 carbon atom we have tetrose, for 5 carbon atom we have pentose, 6 carbon atom we have hexose. Now, we can see this based on number of carbon atoms. We have triose, tetros, pentos, hexos. If you have to say the aldoses, we can say aldotriose, ketotriose, aldotetros, ketotetros, aldopentos, ketopentos, aldohexos, ketohexos. So this is what number of carbon atom, triose, tetros, pentos and hexos. Now the last one, that is this is the fourth one. Then we have a last one, that is the fifth one, and that is based on the taste. Hope you have written this. So we were doing the classification of carbohydrates. However, I've already told this, but I'm writing a classification of carbohydrates. So the first one, fifth one, and the last one is based on taste. Now here also we divided it into two categories: sugars and non-sugars. Now, if we define them on basis of the taste, this is sweet taste, that is having no taste. We can say no sweet taste, but actually it has no taste. For sugars, sweet in taste, and our non-sugar, not sweet in taste or no taste. Anything. Then, second property to define them or to distinguish between them is they are insoluble in water. However, our non-sugars are soluble in water. Insoluble in water. However, our non-sugars are soluble in water. Now, seeing our sugars, there is again one more thing to distinguish between them. It is crystalline in nature and that is amorphous in nature. So, our sugars are crystalline and our non-sugars are amorphous in nature. Let's give some examples also. For non-sugars, we have our starch and cellulose. Starch and cellulose. And for our sugars, we have glucose and fructose. So this was the classification of our carbohydrates. Let me give you a brief recap of whatever we have done. So today we have studied about biomolecules. We generally saw bio means life and molecules. This means the molecules which support the life and forms the basis for our living system. Now, under biomolecules I told you we have carbohydrates, proteins, vitamins and nucleic acid. But today we have covered a little bit of carbohydrates. Now, for carbohydrates, I told you they are optically active compounds of polyhydroxyaldehydes and polyhydroxyketones which are undergoing hydrolysis, either be a polyhydroxyaldehyde or polyhydroxyketone. I'll give an example also for sucrose. That is, sucrose is formed as glucose as well as fructose. That means it has an aldehyde also and a ketone group also. And when it undergoes hydrolysis, it gives glucose, that is the aldehyde group, and it gives the fructose, that is having a ketone group. Then after that I told you about the classification, that is on the basis of, there are 5 bases of classification. So now we have seen our taste, then we had our functional group, then we had our number of carbon atom, then we had our reducing power, then we have our hydrolysis. So this is what our basis of classification of carbohydrates is over. The next thing we will see evidences of glucose. Thank you.